This lesson is on graphing quadratic functions. Quadratic functions all have an x squared, so you're going to see something of the effect y equals x squared. To examine these for the first time, one of the best ways is to make a table, because that's how you started out graphing lines. I chose some values for x, relatively small, -2, -1, 0, 1, and 2. What we're going to do is we're going to plug those into this equation to figure out their corresponding values for y. If I plug in -2, that's going to be -2 squared. So -2 times -2 is +4. Then we do -1 squared. -1 times -1 is +1. 0 squared is 0. 1 squared is 1, and 2 squared is 4. This gives us 5 ordered pairs, and we're going to plot those on our graph. -2, +4, so we go over -2, up 4. -1, 1, so we go -1, +1, 0, 0, 1, 1, and 2, 4. What you'll notice is this is going to be curving. A quadratic function, anything that has an x squared in it, is a smooth curve. This is not making a V, this is making a curve. If we looked at something a little bit larger, like 3, if x was 3, y would be 9. So we would go over 3 and up 9. -3 would also give us a +9. And see how it's beginning to get steeper the further out we go. And then we connect those dots by making a smooth curve. And it continues on forever. All right. Let's graph this one. We have y equals x squared minus 3. So first we're going to square x, and then we're going to subtract 3 from the result. So -2 squared, we said, is 4, and 4 minus 3 is 1. -1 squared is 1, minus 3 is a -2. 0 squared is 0, minus 3 is -3. 1 squared is 1, minus 3 is -2, and 2 squared is 4, minus 3 is a +1. And now we're going to plot those points. -2, +1, -1, -2, 0, -3, 1, -2, and 2, 1. You'll see that same curve is happening right there. Now, here are both of the graphs we just graphed, a little bit prettier and easier to look at. What do you notice is the same about these two graphs? Well, we can talk about some obvious things. Their shape appears to be the same. They're both opening up. They both have this line of symmetry that seems to split both of them. If we folded them in half, they would have a line of symmetry. So they have a vertical line of symmetry. They both have this point right here where they turn. Sometimes it's called a turning point, but when we're talking about parabolas, which is another name for quadratic functions, it's called a vertex, so they both have a vertex. For this one, the line of symmetry and the vertex, they're both on the y-axis. Let's compare their shapes. I'm just going to trace the shape of this one, and then we're going to see how that compares. Look, it's the exact same shape. The tracing isn't perfect, but you can see that the shape is exactly the same. So the shape is the same. What's different? Well, this one looks like it's just been moved down 3 spaces. So y equals x squared minus 3 is down 3 spaces from where the other one is. This one here, the second graph, has 2 places where it intersects the x-axis. So those are called x-intercepts. This one, it's down 3. It also has 2 x-intercepts. The first one only has 1 x-intercept. These are different things we can look at when we're comparing graphs. All right, the special parts of a parabola, and remember I said a parabola is a special name for a quadratic function's graph. It's the actual shape. The first thing that's important about all parabolas is their vertex. That's that turning point. So this red dot here is called the vertex. The purple line is the line of symmetry that they all have. And you'll notice it goes straight through the vertex. If you had could you have a parabola where the line of symmetry didn't go through the vertex? Well, that doesn't make sense because then it's not folding in half. It has to go straight through the middle in order to be a line of symmetry. And then we have these other 2 points that are x-intercepts. All quadratic graphs are not necessarily going to have x-intercepts. It could be something like this where it's above the graph. It could be something like this where it's below. They're not all going to have x-intercepts, but that is an important part where we want to look. All right, on your own, I want you to graph each of these parabolas. I attached a graphs page along with this document for you to graph on. I want you to graph all the first set together. So graph all of these on page 1, but each one gets its own graph. Don't graph them all on the same coordinate grid. And then I want you to graph these on the second page. So you'll need to print the graphs page twice because each one only has 4. When you get to class next time, we're going to discuss all the patterns that we see and how we can predict what the graph is going to look like before we graph it. That's it.